today I've got a pile of Commodore computers that I'm going to try to fix. Now I have some friends down in Sioux Falls that absolutely hoard computers, and this is part of their hoard. They recently got a whole bunch of Commodore machines from a few different deals and sales, and most of them don't even power on. And so being the local Commodore expert, I've been tasked with fixing them. So in the pile here, we have 2 VIC-20s and 4 Commodore 64s in varying conditions. I also got a Commodore Plus 4 up there, which is not a part of theirs, that's actually mine. And I'll probably be making a video about it in the future, but I thought later on in the video I'll fire it up and give a brief demonstration. I also got 2 Commodore printers, which will be getting their own video. Now the objective of this video is pretty simple: fix the computers. Obviously some of them are going to be simpler than others. Some might have simple solutions like fuses blown or need a new capacitor or whatever, which I can easily do in-house right now. However, some of them are going to probably require more advanced work, such as a bad RAM chip or bad PIA chip or something like that. And in those cases, I don't have any of those on hand. So what I can fix, I'll be showing the process of doing so, and what I can't, I'll try to at least diagnose the problem in the video, and then hopefully make a follow-up video after I've ordered some parts to try to fix them. Now here's a bit of a PSA if you're not already familiar with this. These Commodore power supplies are a menace to society. Now what do I mean by that? Well, originally back in the day these things were pretty good quality, or at least there hasn't been a whole lot of testimony of them being particularly bad. Well anyway, for some reason, based on how they were designed, they go bad after years of being old. And this isn't bad like, oh, they stopped working. This is slowly increase output voltage until all the chips on your Commodore board are dead bad. If you have one of these, check it with a voltmeter. There are 2 main lines, 9 volt AC and 5 volts DC, which is especially important and is the main power source for all of the integrated circuits and other functions on the computer. Of the 5 or 6 power supplies that came in my friend's Commodore lot, one of them was outputting 11 volts on the 5 volt line. It would have probably killed the computers immediately. And in addition, 2 of them just didn't work at all. The other 2 that I tested seemed to be okay. Now that worries me a little bit, that there was an 11 volt power supply mixed in the same lot as all of these other Commodore computers. And interestingly, all of these Commodore computers don't power on. So I'm hoping that that power supply, or any other ones, are not to blame, but if they are, that could be a real mess to clean up, depending on how many chips got fried. So here's our first specimen. This is a Commodore 64, and unfortunately all it has to its name is the motherboard itself. Interestingly, it does actually have the power LED, which is useful, but unfortunately I don't have the serial number or anything like that. Now as you can see, there was a little bit of change on the screen, but the power LED is not on. And this is, as I recall when I tested in Sioux Falls, how most of the computers were. Well, I did the most basic of tests, which is to go down all of the chips and make sure they're getting 5 volts, which they are. I also realized that the power indicator LED was actually glowing faintly. Well, I guess it shows up a bit better on camera, but it's not all that noticeable in person. So this is my C64, the one that actually works, and this showed up in a few of my videos. Anyway, what I'm going to do is just start swapping chips from the other computer in here and continuously power it on until I find something that doesn't work. So here's the inside. You may notice that it looks a bit different, and that's because this is a very early production model. It's serial number about 400,000, so it's not like rare first production model, but it's definitely an earlier one. And this is definitely evident by the more spaced out board design and older chips, like these ceramic RAM chips. Anyway, this shouldn't matter because they use the same chips. The PIA chips are the same, CPUs the same, ROM chips are the same. So this is the PLA chip. PLA chip is in charge of basically mapping all of the things on the computer, all of the memory addresses. So like RAM, ROM, IO, things like that. This is the one from the good computer. It works fine. But when I took the PLA from the bad computer and put it in the good computer, I get this. Now it could be worse, it could just be totally not booting at all, but this is definitely strange behavior. Now since the PLA is in charge of memory mapping, my hypothesis is that it's sending the characters right, or it's pointing to the right spot for the actual characters, because you know, you can see all of the letters and characters are right, but for some reason for the foreground color, it must be pointing it to some random spot in memory that keeps fluctuating, which is why we get fluctuating colors. At least that's my theory. And of course, just to make sure I wasn't going crazy, I also pilfered from the other computer, and that PLA chip is perfectly good. Unfortunately, after the integration of a now working kernel ROM chip and a now working PLA chip, the computer still does not boot. Alright, so I've done some more tinkering with it and I've kind of decided to move on. Not that I couldn't get this working, but I've kind of tested all of the socketed chips, all of the important ones up there. And I'm glad I was able to wheedle out some problems, as I determined that the original kernel ROM chip didn't quite work in the other computer, and likewise the PLA chip also had some issues. So at least when I come back to this, I will have probably solved those. Problem is, you get down to these small RAM chips and, well, they don't socket them. So even if I were to be able to desolder them, which I can't really right now, I don't have any other RAM chips to test. But that's besides the point. It might not be the RAM chips, could be the logic chips, could be some stuff over here. I'm not sure. But since this is a loose board, and who knows how it even got to be this state, I feel like this might have been accepting a slightly harder puzzle. So, come next part, I'll try to get back to it and see what to do. But in the meantime, I'm going to move on and try to make progress on the next computer. So this is the next computer. And this is a serial number 1,644,210. And because of that, it's got a revision C, I believe. It's got a later board. Anyway, so my friends who got the Commodores got it from some guy who had a bunch of them. And apparently this was his main Commodore. Hence the fancy keyboard cover. I don't know if I'll be keeping this on or not. I'll have to ask my friend if he wants me to take it off or not. Probably not, because the aesthetic is pretty cool. Well, anyway, functionality-wise, well, it's not. So here's the inside. Now, this doesn't exclusively say that it's revision C, unless I'm blind or something. But it's the one that comes after B, so for the purpose of this video, I'm calling it C. Anyway, I have noticed there is a little bit of writing or something on there. And also, I took apart another revision C board, and it had a big shield right here that had points that touched all of the chips. But it seems to have disappeared, and you can't see it now because I wiped it off a minute ago, but there was thermal paste on a lot of these chips. Also, even the video chip area right here, usually this has a shielded area, whether it's an old or a new board, and for some reason that's also disappeared, so I don't know. I guess somebody's been in here poking around. Alright, well, I've been swapping chips around and I finally have some progress. This computer is now running all on its own right down there. And you know what the bad chip was? It was the video chip, the VIC-2 chip. Look at that, it's a bad chip. And I plugged the VIC-2 chip into the good computer and it doesn't work. And then I plugged the good VIC chip in here and it's working fine now. So I have a simple solution to this one. Now, of course, I haven't attached the video and done other testing yet, but that seemed to be the issue. Unfortunately for the VIC chip, yeah, they don't make those anymore. At least with the ROM chips for basic and kernel, you know, they make ROM chips and people have dumped the ROM, so it's easy to get those replaced. But the VIC-2 chip, that one, unfortunately, you kind of need to go on eBay and just buy used ones. No one, at least to my knowledge right now, as of 2023, no one's made an FPGA replacement, which also makes that kind of unfortunate. But at least I can just go on and buy this one a new one. So until then, I'm going to move on to the next computer. So this is our third Commodore 64. The serial number is somewhere in the 5 million, so this definitely is not one of the older ones. Anyway, I turn it on, we get a flash on the screen. Power indicator light is on, but yeah, it's black. And so here we have another Revision C board. And I think this is what they're supposed to look like with this big RF shield / heatsink. And it's got little arms that go down and touch all the chips with thermal compound. And I guess there wasn't a cage around the video chip like there was in the older ones. They just had a little arm that went down here. On the bottom where the sticker usually is, there's this note that says spare heat sinks need adjust. Check if stored for more than a year, or maybe less than a year. Yeah, I don't know what that's talking about. I mean, it's got the heat sink in there, but I suppose I probably ought to put new thermal compound when I get the chance. So it's the next day, and stuff has changed. Now, I ended up spending a few hours last night working on it. Eventually kind of got late. But I've kind of come to the conclusion that there's a bunch of tomfoolery going on at this side of the board. I haven't even figured out how the chips are yet. So the Commodore power supply system, in my opinion, is an absolute mess. Originally, I thought all it needs was 5 volts, which would just go to power all the chips. And then the 9 volts AC would just get passed through to the user port. Apparently, it's quite the contrary, actually. This is the best diagram I could find, and if you take a moment to look at it, it looks like a bunch of nonsense. I can't make sense of it. Well, I can a little bit, but apparently it needs all of these voltages, and these are regulators, which I figured out. Now, I'm not sure. This might not be for my revision of board. I've already found some inconsistencies. Like, the fuse, for example, is actually right here in the actual computer. But anyway, yeah, so while I was working on this, things would constantly be changing. To put it simply, there seems to be 5 volts going to this, directly from the regulator, and it doesn't go to anything else, just the video chip. And that was fine, but then after a while, stuff died over here or something. In the meantime, over here, I was getting essentially like 0.4 volts on all the chips, but then some of the chips would randomly get 5 volts, or see all these LEDs I have hooked up here, they would also light up sometimes, which they're coming right off of the PIA chips. So somehow they were getting 5 volts. But yeah, things were constantly changing. At one point the fuse blew, and I don't know why. Now, despite how complicated the power supply system would sound, it's only comprised of a few passive components, full bridge rectifiers, and some regulators. And so what I'm going to do is I'm going to take the board out, and unfortunately I have to desolder it because there's a big metal shield soldered to the bottom. I'm going to start probing around. My best guess is it might be the full bridge rectifier, which would be a pretty easy fix because it's basically just 4 diodes. So I've taken the bottom shield off, and I've also jump started this fuse right here. Now, jump starting the fuse like that with alligator clips is generally not a good idea, because now whatever caused the fuse to blow is now not being protected against. However, I need to measure voltages and I need the electricity to flow, so I did it anyway. Now, interestingly, as soon as I did that, everything is working. 5 volt regulator is, well, this is a 12 volt. 12 volt regulator is getting about 17 as an input, which is about right, and a perfect 12 on the output. Likewise, the 5 volt regulator is getting about 9 volts in, which is correct, and it's outputting 5.03, which is going to the video chip and is being measured correctly. Now over here, all of these chips, which seem to get a different 5 volts, they're all getting about 4.97, which is what I was originally measuring a while back. Everything on here is getting 5 volts, including the 5 volt line on the tape drive. And see, when I turn it on, I am getting all these LEDs. Earlier, they would stay on for a second or two, but they'd all kind of flicker on and off, and sometimes this one would stay stuck on, but they're all consistently on now. Now, there's 2 things I changed. One is that I removed the shield. Now, it's possible that there's a short on it, So you can see it's metal, but the thing is, they got this big piece of cardboard material here. So I don't think it was a short, but it is possible. The other change I made was, of course, taking the fuse out. Now, it could be that before the fuse blew, it might have been going bad, and it could be that it was making bad contact or being weird, causing incorrect electricity to flow out the other end, and which was causing other issues. I don't know what that is, but anyway, I've got the computer with correct voltage, although unfortunately it's still not powering on. So we have a bit of an issue. There are only 2 socketed chips on this board. The SID chip, which I've tested kind of and it seems fine, and the VIC chip. Now this VIC chip right here is actually the good one from the other Commodore. The reason being that, well, this original one that came in here, well, I plugged it in backwards and fried it. And the annoying thing was, it actually was working, but the thing is, if you catch plugging it in backwards real quick, you can usually prevent damage, but it took me 10 minutes to realize I had it in wrong. So yeah, this is dead now. That was kind of a boneheaded mistake, but I don't know. Anyway, so I know this works, and I know the SID chip's fine, but other than that, well, yeah, the small things aren't socketed. That's always the case. But even the important ones, like the ROM and the PIA chips and the CPU, they're not socketed, so I can't test them, or at least not easily. So I'm not sure what I'm going to do about this. Well, seeing that most of the things are soldered in, for now I think I'm going to call this done. I kind of did what I did with the first board, where I snooped out a few problems, but it's still not booting. So part 2, I'll try to come back to this when I have more equipment. What I'd like to get from eBay is some chip sockets and some desoldering tools, so I can actually go through, not only test these ones, but also start working on the RAM chips. So I'm going to have to, unfortunately, for now, move on to the next Commodore. So we have the final Commodore 64. This one's serial number is about 1,900,000 something. And it obviously doesn't power on, and I'm not even getting a power indication light to come on, so that's especially not a good thing. Anyway, we look in here and there's all this cardboard nonsense going on. But this board, I don't know if it shows up on camera, it is shiny. Like, I guess this really kept all the dust off. The shield is shiny, the PCB is nice and clean, so that's good, but it doesn't work, so I gotta figure that out. I printed out a real diagram, this one that shows everything, and it even has all of the numbers. So I was able to trace everything back, all the components, to right here. Oh my gosh, it booted. Okay, so I'll get back to that in a second. So I was measuring 0.62 volts over here on the 5-volt line. Now all this other stuff was good because all of the regulators and all the other voltages are derived from the 9 volts AC, but the regular 5 volts that comes off of here is what powers most of this stuff. Anyway, I was perplexed because you can see even all the way up here, right where the power comes in at 5 volts, I was still getting like 0.62, but when I unplugged it and I measured it, I was getting a correct 5 volts. And so on a whim, I decided to try my other Commodore power supply. See, I was using 2 so that I could just, both of these could be powered, and the only thing I would swap is this, so it made it more convenient. I plugged this in, and this happens. Now you'll notice when I open this clip, there's a bunch of garbage on the screen. I was happy to see the garbage, because a black screen, that could be anything. If the computer's not turning on, it could be like literally anything. But if you get garbage on the screen, you could go online and look at guides and stuff and narrow it down. But for some reason, the thing miraculously booted. Let me try doing that again. Oh, well, that's disappointing. Okay, so it's some sort of chip failure, but I did notice, even though it got the welcome message and everything, the cursor was not blinking. So basically what happened was I was getting garbage on the screen, but then after a real long time it finally started, although the cursor wasn't blinking. But after that I couldn't get it to start back up again, not even get garbage, like it was just totally black. So I started doing what I'd been doing all day and started swapping chips with a good one. And eventually I found this. The PLA chip was bad. Now, unlike the PLA chip that was in that other first one that produced flashing colors, this one is just totally dead. So I put the flashing colors one in because it's kind of neat. Oh, I gotta turn this on. And sure enough, as it turns out, all it was the PLA chip. And if I put like the fully working one, the colors wouldn't be flashing. So it seems that I have solved this Commodore. All I need to do is get a new PLA chip, and that'll be installed in part 2. Now there are two VIC-20s, both of which are of the earlier variety that has the two-prong power connector, as you can see here, and this older style looking switch. Now unfortunately neither of them are so rare that they have the PET style keyboard. These are just older ones, although if you notice on this one it does have the monochrome style badge. The other one does not. It has the rainbow badge. In case you're wondering, this has the serial number in the upper 600,000s. I don't remember what the other one is. Anyway, so I've got a bit of a dilemma because I only have two VIC-20s and neither of them work. Whereas with the Commodore 64s, I had one good working one which I tested the chips, and I also had a bank of 4 other ones that I could borrow chips from. So this one might be a bit of a harder puzzle because I only have 2 that don't work. So this is the inside of a VIC-20, and already I'm seeing that it is a whole lot simpler. Thing is, I never really had a VIC-20, so I've never really had the opportunity to work on one. Although I am familiar with how VIC-20s are, I haven't definitely seen the inside of one in quite a while. Anyway, so I got 2 PLA chips there, and that's the one I was talking about might be compatible. Problem is they are of a slightly different number, so they might not even be compatible with the 64. We got the 6502 down there. I'm assuming these are 3 ROM chips. One's got to be basic, one's kernel, and one's character set. And then I guess the RAM is over here, and the video chip ought to be in there. And it appears there's not even a PLA chip, which makes sense because the architecture of the Commodore 64 is quite a bit more involved, especially with the memory map and all the banking. But I guess in here it was simple enough that the 6502 could handle it itself. Well, I've already run into a problem. This 9-volt power supply is giving 11.7 volts, which is obviously not good. And the thing is, I was even going to mention something about how simple these older VIC-20 power supplies are, two-prong variety, because since they only output 9 volts AC, it's basically just a big old step-down transformer. But apparently, these things are also going to overvolt after a while. Well, I just measured the voltage on some of the chips, and they're all getting a nearly perfect 5.03 volts. So I think it's safe to say that even though it's probably 2 volts a little more than it ought to be, it seems that the power regulation over here seems to be handling the 11 volts and giving a good 5 volts. And already I'm starting to notice this capacitor is looking very greasy. So that's probably something to do. It's probably not holding the entire computer up, but I ought to fix that anyway. But that'll have to be a part to order later because I don't have this type of capacitor. Look at this. So this is not that. This is this. This is the other VIC-20, which I couldn't get to power on previously. And look at this. Oh, okay. Yeah, something's very unstable in there. Yeah, so when I first powered it on, I got some garbage on the screen, but eventually it resolved into the welcome message. But it seems something has gone a little haywire in there. The reason I got it out was because I wanted to just start swapping parts. This one, I think I'm going to start work on this one now, because it's more working than that one. And if I can get this into 100% order, then I can start verifying that one. By the way, again, this is another two-prong model, but it's the slightly newer one with the rainbow badge. Here, I'm going to try powering on again to reproduce what I saw earlier. Okay, that's definitely... That kind of looks like the multicolor mode with the double-sized pixels. Well, the interesting thing, too, is that I'm not getting any color at all. It seems to be purely black and white. So I think there's definitely something wrong with the video generation, that is for sure. Yeah, so it seems that besides the video, everything seems to be working just fine. Yeah, see, this is what was happening earlier. I was getting a lot of garbage, but slowly over time, it came together, and eventually, I got the message. Now, obviously, it's still looking all blocky. And so, first off, I'm going to go straight to the VIC chip, because, you know, video problems. But the garbage on the screen, I'm starting to think that could be the video chip, but that could also be maybe one of the ROMs is not making very good contact or something like that. Alright, so I've transplanted the VIC chip from the dead VIC-20 to the less dead VIC-20, and I'm going to see if it looks any different. I don't understand what the deal is with that flashing, but look at this. Now, this would seem bad because the colors are wrong, but immediately it looks so much better. Like, the characters are correct, there's no garbage. Now, the color should be able to be fixed by the turning of a potentiometer. Maybe this other one might also need... I think that's good. So I think we have a working VIC-20. So there we have it. I mean, the colors, I think they were still a little off, but that's up to these two potentiometers right there, which I could continue fiddling with and probably make it look even better. But it would appear that the original VIC chip, well, it wasn't totally dead, as we were getting stuff on the screen, but it was definitely screwed up. So that means between these two computers we have one good working video chip. So that means too that this whole time the video was fine in the other one. So I'm going to have to start looking for other things. But at least I have a computer to verify other chips with. So now that I have one that was actually working, I decided to start swapping chips back and forth. And unfortunately, among all of the removable chips, I couldn't find a single one that didn't work here. So I thought, well, I haven't touched this one in a while. I haven't applied power. Sometimes all you need to do is remove a chip, put it back in, and that can fix a connection. So I thought I'll just apply power, and sure enough, coming straight from this one, it's working now. So it must have been that something was just a little bad connection. So here I'm going to try adjusting the potentiometer. Because the color seems, oh geez, okay, color seems a little dark, and yeah, that's looking better there, because we want a light blue over here and a white there. At least I think so. I haven't stared at VIC-20s too much, but that's looking pretty good. So far for the VIC-20s, I've had a 100% repair success rate. Now I'm not totally out of the blue yet, because between these two I only have one working VIC chip, so I'll need to order one of those, and this capacitor is still looking pretty greasy. So I have to get back to that too. And as I promised at the beginning of the video, I'll give a brief demonstration of my new Commodore Plus 4. This thing is a very different beast to the VIC-20 and C64. Now, it was kind of following the whole thing where they're similar architectures, but they weren't quite compatible computers. But anyway, yeah, this thing is cool. Like, just the aesthetic. Keyboard's a lot nicer to type on. I know people don't really like the weird arrow keys, but I appreciate the fact that there are arrow keys rather than those dumb 3-button or 2-button cursor keys. It's got all of the F buttons up here, and it's even got some built-in software. There we go. This one actually boots up pretty quickly. And already it looks quite a bit different. It's not like the Commodore where it's all blue. It's not like the VIC-20. It's got black text on white, kind of like paper. I haven't really messed around a whole lot with this computer. So I don't know. But it's got a newer version of Basic, which is very good because it's got like graphics and sound commands. But the main selling feature was that it has built-in software. So this is the word processor. And again, I haven't really looked into much of anything, so I don't know how to access the other ones, but I just find it nice that it has all this stuff built in. And at the same place we got this, I also got the matching printer, which I don't own. It's one of my Sioux Falls friends. But I have it with me, so I'll see if I can get the printer to work in another video. Well, I guess that concludes this video. Now, I had a lot of fun with this. I mean, even just seeing this pile of Commodore stuff in my room is like 12-year-old me's dream. I finally got a whole bunch of these old computers to mess around with. But of course, the story's not over yet. Even though I've solved a few of these, there's still the other two C64s I have to fix. And there's also all of the new chips that I'll have to install. And so in part 2, whenever that comes out, hopefully before the end of the year, I will be receiving all the new chips from eBay or wherever, installing them, and trying to fix the other ones. In the meantime, if we take a look over here, right there's 2 Commodore printers, and that's going to get its own video. Again, I'm not really sure when. But that one right there, the matching +4, it's got ink cartridges that are still sealed, so I have good hopes for that. Anyway, that's going to be it for this one, so I hope you enjoyed, and I'll see you in the next one.